everybody. Thanks for being here. We have folks in the room, for those of you who are joining us online and can't see us. We have folks in the room, we have folks in the Zoom room. And so I just want to welcome you to today's Smart Safety Connection Seminar. My name is Selena Disler, and I'm the Program Manager for Safety 21, which is a US DOT University Transportation Center. This seminar series is sponsored by Safety 21 just to provide faculty an opportunity to showcase their current transportation projects. And it's also an opportunity for students, faculty, deployment partners, and the broader community to engage and network with researchers and highlight opportunities for involvement and hopefully foster future interdisciplinary collaboration. Please note the session is being recorded, and I'm going to try to keep all participants' microphones muted. If you're joining us online, you're welcome to send questions through the chat, and if you're joining us in person, feel free to raise your hand. You don't need to wait to the end of the presentation to ask questions. You're welcome to ask them throughout. And so now I want to get to the meat of things by introducing our speaker today. So we're really lucky to have Dr. Noosheen Nazari, who's an assistant professor of civil engineering at the University of Texas, Rio Grande Valley, or UTRGV. She's a faculty affiliate of the NSF CREST Center for Multidisciplinary Research Excellence and Cyber Physical Infrastructure Systems at UTRGV. And she's a part of the US DOT Safety 21 National University Transportation Center, which is led by by Carnegie Mellon University. Her research interest is in human-centered smart transportation systems, crossing disciplines such as economics, psychology, computer science, and mathematical science. Her research has appeared in premier transportation journals, such as Transportation Research, Part C and Part D, and major conferences organized by, for instance, the National Academy's Transportation Research Board, the International Conference on Travel Behavior Research, and the Institute for Operations Research in the Management Sciences. She has actively served the professional community through journal editorial board membership and paper review, as well as technical committee membership, such as serving on the TRB Standing Committee on Travel Behavior and Values. So Noosheen, we feel lucky to have you here today, and I will turn it over to you. And I'm going to mute us and turn off our camera here.
Thank you. Hello, everyone. Thank you for the invitation and for the introduction. Let me share my screen. Okay. So is my screen fine? Is it showing? Okay, great. Okay. Okay. I'm very glad today to present our recent research results on planning and policy for safer roads with autonomous vehicles. And specifically in this study, we have focused on decision-making of autonomous vehicles in dilemma situations. Autonomous cars or AVs, autonomous vehicles or AVs is an emerging technology, and we are witnessing services provided by different companies, and these technology is in public roads now. And one of the pioneering companies providing these services is Waymo, and Waymo is offering the services in various cities in the country, and these cities are increasing one by one every day. We have services in San Francisco, Los Angeles, and Phoenix. But despite this growing services, public is still concerned about the safety of this technology, and the trust is not widespread by all people. Let's look at some numbers about the concerns that people have. As reported by AAA, over the past years, people are still concerned about this technology, and American drivers are afraid of AVs. 66% of them are afraid, and 25% of them are uncertain about the safety of the system. And the point is, this concern has been consistent during the past years, and it's been even increased. So the problem is how we can study public perception of the safety concern and how we can design policies to decrease this concern. In our previous study, we have focused on acceptance behavior, adoption behavior of autonomous vehicles or AVs. And our results show that safety concern is a dominant factor among many factors affecting this adoption behavior. We also investigated this concern in a recent study published under Safety 21 on how this concern forms, what factors affect this concern, and at the same time, how this concern affects adoption or acceptance behavior of AV. However, this safety concern can have various dimensions. People might be concerned about the equipment of autonomous cars, its object detection, or its navigation, or many aspects of AVs. One of the aspects that causes this concern is the decision of AVs in critical situations. Imagine a situation where an AV should decide about the safety of the passengers on board and the pedestrians on the roadway. But how should AV make decision, and how this decision of the AV affects public perception and acceptance of this technology? So this critical question kind of is a kind of a deeper layer of public safety concern, and this is the focus of our study, to see how this concern forms and how it affects acceptance or people's willingness toward this technology. And accordingly, the policy design for integrating this technology in our daily life should have a balance of technical feasibility and social acceptance. Previous work have focused on this aspect of AV safety from different angles. For instance, some studies have focused on how should be the takeover maneuver, the takeover of the driver and AV to control AV decision in critical situations. Or other studies have investigated various algorithms for preferences and so on and so forth, as I have listed here. However, there are still some gaps in the existing studies, including lack of industry practice. Most of the studies overemphasize on the philosophical aspect of the safety issue, and the experimental part of it is almost missing. And furthermore, the studies lack public acceptance, public preferences when they are investigating these safety situations. Also, most of the models developed, most of the paper studies done focus more on model-driven approaches, and there is a need for more data-driven approaches to investigate this research question. So to address these gaps to some extent, we have phrased our research question as how public actually expects AVs to behave in specific contexts, in real-world scenarios, when there is a decision between the safety of the passengers and pedestrians. And we have tried to develop a data-driven modeling framework. We have designed a survey for that purpose. We have developed our modeling framework based on this data-driven approach, and the results are utilized for design for policy insights to provide suggestions for future. For this purpose, we have developed the modeling framework, as you see in this slide, by phrasing the questions that can understand people's concern in these specific situations and try to connect this concern to their attitude toward AV. Specifically, we have narrowed down our focus to two specific questions: whether people feel confident in AV safety, or are they willing to, and also are they willing to ride with an AV? What we have done here is to try to design various scenarios in which AV needs to make decision between pedestrian and passengers. And we have asked people's opinion about confidence in AV and willingness to ride in different scenarios. So we have one base scenario that there is no decision situation, and four different scenarios with different specification that people express. I mean, individuals of the survey express their opinion about confidence and willingness to ride. And we have used dynamic Bayesian network-based modeling to model the connection of the different scenarios with base conditions. And we have done simulation with different methods to evaluate the results. In addition to individual responses to various scenarios, we have collected their basic information like their demographics, their travel behavior, their familiarity with AV, and various attitudes related to the decision that I will talk more about this in the next slides. And here is a very summary of the dynamic Bayesian network-based modeling. The equations are listed here for the sake of time. I skipped this part. And then all these questions and all these scenarios that I talked about have helped us to design a survey which is disseminated in two specific cities in the US, San Francisco and San Antonio, to give more context to our study. Since San Francisco and San Antonio have different exposure to this technology, so we try to further analyze our results by giving context to our survey. After designing the survey, we disseminated in these two cities and collected a data set including of almost 350 observations, and then we cleaned the data and did all the required primary steps. Then we try to run our proposed model on the data set. But the scenarios that I talked about, the base versus the four scenarios, if you want to run this dynamic Bayesian model only on these scenarios, our model will lose heterogeneity. So we need further information from the individuals to give variation of taste of different individuals, which will be helpful for our policy suggestions. So specifically, we have focused on demographic characteristics of individuals and also their attitude toward different decision making that I will talk in the next slides. So to select which attributes can better capture this heterogeneity, we first focused on demographic factors that are basically the primary cause of heterogeneity, the direct cause of heterogeneity, which are observable. And we tried to measure influence of various demographic factors on people's attitude toward AV, specifically their confidence in AV safety and their willingness to ride with AV without considering any scenarios, only in the base conditions. And we found that household structure, employment type, education, and age are among the top ones that affect safety concern and willingness to ride. Here is for safety concern, here is willingness to ride. So we have selected demographic attributes with the highest importance values to enter our dynamic Bayesian network model. Then we need more, in addition to demographics that give observable heterogeneity, to our data, to our model, we need more heterogeneity factors. We need to capture different tastes that people have, which is hidden and not observable and measurable by something like household structure, age, and so on. To do so, we have designed various questions in our surveys, a series of statements that individuals
Noosheen, are you still there? We've lost you.
The well, to give more context, so this is our overall framework for analyzing the effects of various safety scenarios on how individuals decide about willingness to ride with AV and their confidence in AV safety. And for giving for considering more the heterogeneity of the respondents, we decided to select more attributes for the individuals to give it more context. Specifically, we focused on demographic attributes of individuals, and we ran multiple analysis to select those attributes that affect the most and explain heterogeneity of the sample better. And we found that household structure, employment type, education, and age are among the top ones. So we incorporated that into our dynamic Bayesian network as like the parent nodes. And then we observed that this is not sufficient to only account for observed heterogeneity by considering demographic factors. So we decided to go into the latent attitudes that people have, and they form about various decision-making situations. And we try to derive this latent attitude and incorporate it in our dynamic Bayesian network model. How did we do that? We designed various survey questions that are in form of statements that they measure how people make decisions in their daily life and how they're and in what style people make decisions. And based on individuals' responses to these statements, which is measured by Likert scale format questions, based on their response, we try to derive these latent classes. So this response can try to capture people's emotions versus rationality, which are cognitive emotional dual process drivers that are based on psychology. And also we try to measure their preferences in deontology and utilitarianism, which are reasoning styles in dilemma situations. So we, as I said, we have designed various statements, and some of them are listed here in the table, as you see. And then we ran a latent class clustering analysis to try to relate people's response to these statements to other factors so we can derive various classes. So the results show that there are 4 types of classes in our sample data set. The first type we labeled as detached decision makers that are not that much responsive to any of the decision making aspects. They have low engagement across all measurement indicators, and they have weak reliance on either emotional or rational cues. The second class, the first class is shown by blue color here in this slide. The second class, which is the orange one, they are highly engaged, they are highly emotional, they are across both emotions and rationality, they have high engagement. The third class is called utilitarians that try to make decisions based on pros and cons. And the last group, which is shown by the red line, are those that are balanced in various aspects, balanced in emotions and in rationality and so on. So what we did next is to run our dynamic Bayesian network model to see the effects of, to see how people decide about ABEs given heterogeneity explained by demographics and also the latent class that I just explained. Now let's go to the results. We ran our dynamic Bayesian network model and we ran multiple simulation types. Here I just present the empirical mixed simulation results. So in this slide, you see that we have analyzed impact of the 4 scenarios on AV on confidence in AV safety. Well, regardless of any scenarios proposed to individuals, their confidence is relatively high for highly engaged class and is relatively low for detached decision makers. But when these various scenarios are offered, individuals are exposed to these scenarios, their confidence decreases. What are these scenarios? In the first scenarios, the individuals are asked, do you have confidence in AV if the AV prioritizes passengers over or prioritizes pedestrians over passengers unconditionally, and their confidence has dropped sharply. In the second scenario, they're asked, do you have confidence in AV if passengers are prioritized in case pedestrians break law? Then again, their confidence decreases compared to the base scenario, but the decrease is lower than the first scenario. In the third one, in the third scenario, pedestrians are prioritized if there are children. And in the last scenario, pedestrians are prioritized if their number are more than passengers. So in the last 2 scenarios, confidence in AV safety decreases compared to the base scenario. How about the willingness in AV in ride with an AV? Similar to confidence, it decreases, but the decrease is more sharp here than the confidence across all classes. As I mentioned in the previous slides in our survey design, we collected our data set in 2 separate cities, San Francisco and San Antonio, to give more context and to be able to have a stratified analysis for our study. As you see in this slide, overall, individuals living in San Francisco have higher confidence in AV safety compared to those living in San Antonio, probably because they are more exposed to this technology. And for across all classes, their confidence decreases when they are exposed to safety scenarios, whether passengers are prioritized or pedestrians are prioritized. But this decrease is sharper when pedestrians are prioritized unconditionally in both of the cities. But overall, as I mentioned, this decrease for San Francisco, this willingness in San Francisco is higher than in San Antonio. The same thing for willingness to ride. As you can see here, San Francisco has higher values. Now, based on the results that we derive, let's come up with a number of policy insights and see if we can use these the results of this dynamic Bayesian network individuals' response to various scenarios. Let's see if we can derive any insights for designing practical policies. We observed that we found that regardless of any latent class segmentation and any cities, there is a sharp drop in confidence in AV safety and willingness to ride when pedestrians are prioritized unconditionally. So this may imply that rigid and zero context passenger sacrificing rules might result in sharp decrease in confidence in AV safety and willingness to ride. And now let's see if we change these scenarios, these policy scenarios, how a reaction of individuals changes. When we have rational rules like pedestrians break the law, passengers are prioritized, or if pedestrians are children, passengers are prioritized. When we see these scenarios, still confidence in AV safety and willingness to ride decreases, but this decrease is relatively moderate compared to when we have no conditions. How about when we have majority-based rules, like when pedestrians outnumber passengers? In this case, the decrease in AV safety is still happening, but the pace is lower compared to the previous conditions. How about the different classes that we talked about? Cold utilitarians, detached decision makers, highly engaged people, and balanced integrators. What is the effect of this latent segmentation on various on the outcome under various scenarios? Those that are highly engaged, have high initial trust in AV, they show largest sensitivity. When scenarios change by prioritizing passengers and pedestrians, these people react sharply and with more strong sensitivity, especially in San Francisco. So these finding again emphasizes that trust inclined groups can become less interested in AV if policy suggestions are not designed for them. How about the effect of different cities that we considered here? We found that individuals from San Antonio have more stable opinions and compared to San Francisco. So they remain relatively stable across the various scenarios, especially those groups that have lower initial trust in AV and they live in San Antonio. Their opinion does not change by offering various scenarios to them. Again, this overemphasizes on region specific policy suggestions if we want to improve popularity of AV among people. So what can we do in future? In future, we suggest two main avenues for improving the work. One is working on the generalizability of the results by transferring the results from one area to another to see if the same findings still working in other areas. And also in the second direction, we suggest going beyond only stated preferences surveys that we did in the current study. We go beyond that and we collect more other types of data like physiological and affective data measured by various devices like EEG that can see how what brain activity is under various scenarios that we designed here, and try to relate them to the taste heterogeneity that people have and their opinion. So with all that, I conclude my presentation. Thank you all for your attention.
Thanks, Noosheen. Okay, we'll turn it over to questions then. So I'll try to put the camera on in the room. But in the meantime, if you're on Zoom, you can feel free to take yourself off mute, or you can write in. We have a question. Go ahead, please.
Oh, sure, totally. Hi, thank you for the wonderful presentation. Can you hear me?
Yes.
Awesome work. I was really interested by how you drew this contrast between respondents from San Francisco and San Antonio. I'm really thinking about the exposure to AV as a technology. What I thought was also interesting and a possible node for future elaboration of the study is consideration of city infrastructure. I'm going to be honest and say that I personally have never been to San Antonio, but to my knowledge, it is a relatively car-dependent city and a car-dependent metropolitan area. So I wonder if you would see similar responding contrasts depending not only on technology exposure, but the infrastructure that these respondents are using day to day.
Okay. Thank you very much for your question. That's a really valid point. So let me go back to this framework that we proposed here. Our data set includes various information on both sample from San Francisco and San Antonio. We have demographics, we have travel behavior profile, which are measured by various variables like if they're car dependent, what is the frequency for various transportation modes, bike, walk, public transit. For both cities, they are measured, and also AV familiarity. What we did in this study is to go selective and try to choose only a few of these variables in our dynamic Bayesian model, because dynamic Bayesian model is very computationally needs high computational power, and we cannot give many variables as input. So to choose among even sociodemographic characteristics, we had to be selective. But we will definitely try travel behavior profiles in the future and see maybe these profiles explain heterogeneity even better than demographics. And thank you for your suggestion.
Thank you so much for your presentation. Sure. Great work.
Sure. Thank you.
Okay, ask the question?
Sure.
As a pedestrian and a bicycle rider, when you come to like a four-way stop or an intersection, they always say before you proceed, you should make eye contact with the driver. So with an AV, how would I know that the vehicle is actually sees me? And so we don't get into a standoff as far as who's going to go first, that type of thing.
Great. Thank you for your question. Yes, that's really a valid point about perception of AVs in various situations. So what we have assumed here is that AV clearly sees everything in front of it, sees pedestrians, if even can count number of pedestrians if they are numerous compared to passengers. So our assumption in this study is that clear understanding of the surrounding area, surrounding environment of AV, but that would be definitely a very, very good suggestion for future work to see if we change, this visibility of AV decreases to some extent, then how would people trust in this technology?
Other questions? Oh, sorry, I just missed you. Please.
I just want to make sure that no one else has any questions. Okay, of course. I did find it interesting that you suggested in further elaboration of the study that you want to ensure that the study is non-culturally specific. Is there anything in how the survey was designed or how you formulated this research that you had concerns around cultural specificity as is? Or is that more of just sort of a general social scientist concern that you had? As
Uh,
interesting as it was.
So, if I understood your question, is that why I consider two different cities and how did I differentiate between San Francisco and San Antonio? So, well, our first idea for distinguishing between San Francisco and San Antonio was because San Francisco people are more exposed to AVs, and their travel behavior is mainly different from people in San Antonio. But the general, the more general question is that, okay, assume we develop separate models for each city, can we come up with like a generalizable rule for all of them, no matter who lives where? So all these various questions were all of them were in our mind where we were designing to narrow down our specific question, and we came up with this survey. So I hope I could answer your question.
That was helpful, thank you.
Any other questions or any other questions in the Zoom room? I'm not seeing anything in the chat, but you're welcome to take yourselves off mute. Well, I think I just answered everyone's questions, Noosheen. And last chance, anybody? Oh yeah, do you have a question?
It's a silly question.
No,
Just
please.
wondering, in your research with the AVs, do you ever, I know how you said it was prioritizing if it was a child or an adult for the study, but did you ever realize that it seems like the AV vehicle seems to want to protect itself more than protect a human being? I have actually got AVs, I do have AVs now, and I really feel as though the vehicle is more concerned about itself.
Yes, that's a good question. Well, actually, what AV is thinking is something. What AV is deciding, whatever rule it is, it's something installed on it. So, for to come up with a rule for AV, we were trying to very indirectly account for the question that you asked by asking individuals how they make decisions in their daily lives. Are they, for instance, in one of the measurement indicators I listed here, we measured if they think human life is prioritized to property or not. So we were trying to very implicitly consider that if human life is more important than property. So I hope I could answer your question.
Thank you. A very nice presentation too.
Thank you.
Anything else? Okay. Oh, there's a question. Thank you. Thanks. Okay, Noosheen, it looks like there's a question in the chat. Have you done similar research with pedestrians?
Uh-huh. Yes. That's a very good question. Here we just focus on how people prefer AV given these situations, but there are previous studies focusing on public opinion, regardless of if they are pedestrian. Assume they're pedestrian, will they accept to be AV around them on the streets with these features? So there are other studies that have previously done that, and also general public opinion about AV regardless of they are either pedestrian or passenger or anything. So it's like a third person view overall. I don't remember exactly which study it was right now, but I'm sure there were previous study doing that.
Great. Thanks, Noosheen.
Sure.
Yeah, they followed up as a
Mhm,
pedestrian. Would you like to
mhm.
see AVs? Yeah,
AVs.
good with that. Perfect. Anything else in the Zoom room? Great. Well, I will wrap it up here. Perfect. Okay. Thanks, Noosheen. Really happy that you could be here with us today. Thank you for your presentation. Thank you to all of you for coming. Thanks to all of you in the Zoom room. We will make sure that we will post this presentation. So if you want to watch it again, or if you want to share it with someone, it'll be posted on our website probably on Monday. And if any of you are interested in engaging more with transportation topics, there's a transportation club here on CMU's campus. But I hope that you'll come find us if you have any other questions or want to engage with transportation in other ways, because we'd love to connect you with the right resources. So thanks again, Noosheen, and thank you to everybody for being here.
Thank you.